Hello there, my name's Rusty Scaggs. I'm with Marine Water Heating Division. I want to talk to you just a minute about water heaters, basics about them, gas and electric. One of the things I want you to understand is that water heaters and furnaces take up 60% of the energy. They're responsible for 60% of the energy use in your house. So it's extremely important to make sure they're installed properly, vented properly, and functioning the way they should. Okay? So let's talk about water heaters. I don't do heating sides, so we'll talk about water heaters. As far as ways we heat water two ways. We do gas and we do electric. We're going to talk about electric first, then we'll get into gas and the different parts of it. As far as an electric tank, it's pretty basic really. You've got your tank, your fill tube, you've got your upper and lower elements with thermostats, your drain, that's pretty much it, and where you plug in on top, where you're wiring it in. The way we heat with electric, we run power through those two elements, and they can be different wattages, anywhere from 3,000 watt to 6,000 or 8,000 watt. We run electric through those elements that heats that element up, which is in the water, and it transfers the heat to the water, and that's how an electric water heater works. Now, as far as the element itself, they can be copper jacketed, they can be titanium jacketed, stainless steel. There's several different ways to jacket that element so that it'll last longer. All of our ream heaters typically have stainless steel in the Pro Series, which you're getting from Robertson and different places like that. As far as testing that element, there's two ways to test it. You can test it through continuity, or you can test it with ohms. Continuity will tell you if you have a complete circuit. However, if you've got a broken element and there's a calcium bridge built up across there, because when you heat water, minerals become solids again and they attach to things, and it can build a bridge across that gap. So that if you did a continuity test, let's say, just to see if you had a complete circuit, that calcium bridge can conduct, so it'll still show that you got continuity, not telling you if that element's good or not, just says you've got a complete circuit. That's when you need to do an ohms test. To do that, you're going to want to make sure, and before you do the other test as well, turn your power off on the heater, take the two wires off the element, undo the screws, and take the two wires off of them. Now you've done your continuity check. You've got continuity, but you want to make sure. So what you're going to do now is you're going to set it to around 200 ohms on your meter, your multimeter. Touch one lead to each screw. You should read somewhere between 10 and 16 ohms. That range is going to vary depending upon the power or the wattage of that element and the voltage that it's rated for. For example, if you had a 4,500 watt element and you've got 240 volts going into it, the simple math for that is you would multiply 240 times 240, or square your voltage, then you divide that total by your wattage, which let's just assume 4,500 watts. If you do that, you're going to come up with around 12.8 ohms is what that element should read. So that way, if you want to nail it down to the fine point and exactly what you should have, that's the best way to get it. Okay? Now, once you've tested the elements, the other things you've got on there are thermostats that control the heater, control the elements themselves. Now, as far as which element does the most work, your lower element actually does 80% of the work in your heater. Your upper element, when you fill that tank up and flip the power to it, is going to heat up that upper third. Then as soon as its thermostat is satisfied, it's going to transfer the electric down to the lower element. And then the lower element is going to heat up that lower 2/3. This is called non-simultaneous operation. All residential heaters operate that way, one or the other. You'll never have both elements working. If you do, that's called simultaneous. That's in commercial work. The reason we do non-simultaneous in residential, that allows us to go onto a 30 amp breaker in that breaker box. If you went simultaneous and had them both going, you would have to jump that to a 60 amp breaker, and a lot of people don't have that much room in their breaker box. Okay? So that's how that works. Once both are satisfied, they're both going to turn off. The thermostats are satisfied, they both turn off. The tank is sitting there full of water. You turn a faucet on, cold comes in, starts diluting the water at the bottom and tempering it off. That lower thermostat says, hey, we're getting cold down here, and it kicks its power back on, starts trying to keep up. Now obviously it's a tank heater, you're not going to keep up depending upon how much drain you're putting on it. So as that cold water's filling through the bottom, as it passes, when it reaches that upper element and it senses the cold, it at that point is going to say, okay, you're not doing your job, I got to take over, and it takes back over again. Then your upper element kicks back on and tries to keep up. But like I said, a tank heater, you will run it out of hot water. I don't care how big it is. If you put enough demand on it, you're going to run out. Okay, that's electric heaters and pretty much how they work. Now let's talk about gas for a minute. Okay, gas heaters, as far as the tank itself, it's pretty much the same. You've got a tank, you've got your anode rod, your fill tube, you've got your drain on the bottom, but you have a gas valve now with a burner assembly instead of having elements. You also have a flue that runs up through the center of that water heater from the burner to exhaust your flue gases. The way it works, you fill it up with water. The thermostat for the gas heater is in that gas valve, and it's actually in a nodule that sticks out on the end of it. You turn the gas on, hit the spark to light your pilot, turn it on, get it lit, it's going to light, then it starts heating. Just like a pot on a stove, it's going to heat right through the bottom of that heater. However, that's not the only place it's heating. You also have your flue going up through the middle that I was talking about. That has a baffle in it that's set different ways to slow those flue gases down. As it slows those flue gases down, the heat is then extracted out through the flue into the water, so we're heating water all the way up through the tank. Mainly on the bottom, but we're also heating up through as we go out, okay? That's how a gas water heater works. Once that thermostat's satisfied, the gas is going to shut off, the flame goes out, and it sits there and waits for it to get cold again. Same thing if you turn a faucet on, you introduce cold into the bottom, it's going to sense the cold, it's going to fire the heater back up and start reheating the water. That's how it works. Now, something that's very important, well, before I get to venting, let's talk about thermocouples and ECOs. Okay, you have an ECO and a gas valve. You also had one on your electrics, but we're going to talk about the gas valve. You have an ECO. It's a fusible link that is out in that probe that's sticking into the tank off that gas valve. That fusible link is supposed to melt at 190 degrees. When it does, it shuts the gas off and kills that valve. That valve is done now. You can't fix that fusible link. You have to replace the valve at that point. However, what that does is keep you from running boiling water in that heater and creating steam, and it's called a runaway heater. That's a prevent a runaway heater. Okay, once that happens, like I said, you've got to replace that valve. Now, to test that ECO, if you want to see if that's what the problem is, because the ECO and the thermocouple will give you the same indication. When you go to light your pilot, you hold your pilot button down, hit the igniter, and that pilot lights. Well, that the flame is hitting the thermocouple. The thermocouple is two dissimilar metals. It's a core metal with a jacket, and when you apply heat to that, it creates electric, milliamps of electric, or millivolts, I'm sorry, millivolts of electric. So those millivolts of electric go back up into that gas valve, and you're holding that button down. Well, you're holding a plunger open. Underneath that plunger is a small electromagnet. Those 24 millivolts of electricity coming from that thermocouple energize that magnet and hold it open. That lets your gas come through and light your burner. If your thermocouple's bad and it's not sending that voltage up there, when you let go of the button, the pilot's going to go back out. If the ECO is bad, when you hold that down, it will light just like when you're doing the pilot or doing your thermocouple. It's going to light just the same way. However, when you let go, it's going to go out, because the ECO circuit is part of the thermocouple circuit. It's all one circuit. So either one of those bad is going to give you that indication where your pilot will not stay lit. Okay? Got to test them both. To test the ECO, you take your thermocouple loose off the bottom of the gas valve, take one of your leads, touch it to ground, set your meter to continuity, then take your other lead and push it right up in where your thermocouple unscrewed from the gas valve. Now you got to be real careful not to hit the sides, like the old game operation. You got to get right in the middle. You get right to the middle and touch that center. If you have continuity, that's saying that ECO is good. So if your pilot's going out, then you definitely have a bad thermocouple. Now, how you can test the thermocouple real quick, while you've got it unscrewed, leave it inside the unit. Alligator clips are the best way to do it. If you don't have alligator clips, have another buddy come in, because you're going to need a third hand. You're going to hold one lead right on the tip that goes up inside the gas valve off the thermocouple, the other one on the jacket or the outer metal or ground on the heater, if you want, either way. And then hold the button down and light your pilot. While that pilot's lit, and set your meter to millivolts, about 200 millivolts. While that pilot's burning, it's going to heat that thermocouple up, and you should see your meter go up to somewhere between 20 and 30 millivolts. 24 is usually where they're going to land, but anywhere from 20 to 30 is saying that's a good thermocouple. If that's good and your ECO was good, you definitely have another problem if your pilot's not staying lit. But that's how you would test those two items, okay? Now, on both on gas, we're going to talk about venting real quick. There's 3 ways to vent. You can vent with atmospheric, which is a B vent. You can vent power vent, which is a PVC pipe running your exhaust outside and you're still drawing room air for your combustion. Or you can do what we call power direct vent. Power direct vent, you're pushing your exhaust outside, but you've also got a pipe running outside pulling in your combustion air. This is real important. Combustion air, you need to have it, guys. If you're sticking a water heater in a little closet, you need to make sure that closet's got louvered doors on it, okay? The math, and I'm not going to do it all, but I'll tell you what the formula is. For every 1,000 BTU of burner, you need approximately 50 cubic feet of combustion air. So just to give you an idea, 199,000 BTU tankless unit would require 10,000 cubic feet of air. That's roughly a 20 by 50 by 10 foot room. And nobody's got their tankless sitting in a basement that big that's empty. Okay? Same thing with tank heater zone. We've never really thought about it. We've just put them in closets. Well, if you did that and you don't have a grill on there or cut 3/4 of an inch off the bottom to where you can get some combustion air in there, that's why those things will soot up. They won't burn properly. You'll get yellow flames, and the heater will not perform the way it should. That's what I was talking about in the beginning. They need to be working efficiently, and it won't if it doesn't have the proper combustion air or gas. Okay? That's venting. Last thing I'm going to talk about is the TMP valve. I'm going to get on my soapbox for a second here because this is the most important safety device on a water heater. The temperature and pressure relief valve, which is set to go off at 150 psi or 212 degrees, okay? When you read anybody's TMP valve, if you read the manufacturer's recommendations for the TMP valve, whether it's Watts or whoever makes it, or even ours, Rheem, A.O. Smith, and Bradford, we all tell you to test those TMPs yearly. Must be tested yearly. That device is an extremely important part of that heater. What happens if they're setting in for more, let's say that heater's sitting there for 4 years and that thing's never been tested, got really hard water, you're separating elements out of that water. Those elements will actually, those minerals will start collecting inside that TMP valve. You've got a temperature probe sticking in there that's loose that measures your temperature for the 212, but you also have a diaphragm in there that releases at 150 psi. You get enough mineral buildup in there, now that can't open, it can't do its job. If you ever go into a water heater to do a service or replace and you see the water heater's got the hot and cold or pointing towards each other on the top, check your TMP. 99 times out of 100 the TMP is failing because what's happening as pressure builds in that heater, and when you're heating water it expands so you get pressure buildup. As it builds, if it doesn't have anywhere to go, that TMP is not relieving it, then it will start spreading that tank and actually stretching that tank, and that's what makes that hot and cold come in together. Now they don't spring back, they stay that way because this isn't spring steel. It's going to stay there. Eventually, if you don't correct the problem, you've got a good chance of the side just splitting out of that heater and flooding the house, or it could be even worse. There is a situation where a gentleman plugged a TMP in a school in Oklahoma back in the 70s or 60s. It was in a cafeteria of a school. Water was dripping from the TMP, running out from under the door. Ladies were complaining, so he just went in and plugged it. It built up enough pressure. This was an 80-gallon atmospheric gas heater. When it blew up, it took the entire corner off of that school building, wiped out the cafeteria, killed teacher and 5 students, and injured 35 others. That TMP is important. If you've ever watched Mythbusters, the old Mythbusters thing where they actually plugged the TMP and shorted the electric heater so it had to just sit there and keep cooking. Eventually the bottom blows out and it's like a missile going through 2 floors. It will happen. It definitely will happen. So I'll get off my soapbox now, but test those TMPs yearly. It's important. And that's gas and electric water heaters, the basics. If you need any more information, I'm always out there for you. Call me, I'll tell you what I can. Thank you.